Okay, this is part 2 of graphing quadratic functions. We're going to look at functions, quadratic functions here of the form ax squared plus bx plus c. The first thing that you need to know how to do to graph a quadratic function is to find its vertex. And there are a couple ways to find the vertex of a parabola. The method that I'm going to show you here is where we use the axis of symmetry. The axis of symmetry is found by using this formula, x equals negative b over 2a. And we're going to use that to find the vertex of our parabolas. Okay, so as our first example, find the vertex. We have a quadratic function, y equals x squared minus 4x plus 5. Now it's in standard form. A is 1, it's the 1 right there. B is negative 4, and C here is 5, but we don't need C for the axis of symmetry. So our axis or line of symmetry is x equals negative b over 2a, and that is going to be here negative 4 over 2 times 1, and that will simplify to a positive 2. So our line of symmetry is x equals 2. That's the first part of the vertex. Now I just need the y value, and to get the y value I take x equals 2 and I plug it into our function to solve for y. And if I do that, I get y equals 2 squared minus 4 times 2 plus 5. And if I simplify that, I get 4 minus 8 plus 5, which is equal to 1. So our vertex for our parabola here is going to be at 2, 1. We found the vertex using the line of symmetry. Let's do one more example of that. Find the vertex. We'll take the function y equals negative 2x squared plus 3x minus 1. Okay. Line of symmetry. Here is going to be x equals negative b over 2a, which in this case is going to be negative 3 over 2 times negative 2. Simplifying that, I get a positive 3/4. So our line of symmetry is x equals 3/4. I plug that in to solve for y now. So I'm going to take this and plug it in here for these x's. Y will equal negative 2 times 3/4 squared plus 3 times 3/4 minus 1. This is negative 2 times 9 over 16 plus 9 over 4 minus 1. And this reduces to negative 9 over 8 plus 9/4 minus 1. And if we get a common denominator for our fractions here and add all that up, we end up with 1/8 for y. And we have found the vertex of this parabola. It will be located at 3/4, 1/8. And we found the vertex using the line of symmetry. Okay, now we're ready to graph a couple parabolas. As our first example, we will graph f of x, or y, equals x squared minus 6x plus 5. Now for this function, the a equals 1, and if you recall from the previous lesson, the a value determines which way the parabola opens. So I know that since A is positive here, my parabola opens upward. So my parabola is going to do that. Now I'm going to find the vertex. And I'll use the line of symmetry method. Oh, 2 there. Negative b over 2a, which here will be negative 6 over 2 times 1, and that simplifies to 3. So our axis of symmetry is x equals 3. I plug 3 into the function to get the y value. F of 3 is going to be 3 squared minus 6 times 3 plus 5. And if I simplify that, that's going to be 9 minus 18 is negative 9 plus 5 is negative 4. And so I have found the vertex of our parabola. The vertex is at 3 comma negative 4, right there. Okay, I'm going to start graphing. I'm going to plot the vertex and the axis of symmetry, keeping in mind that my parabola is going to open upward. 3 comma negative 4 is approximately right about here. And the axis of symmetry, x equals 3, is a vertical line which goes right through the vertex. We use the axis of symmetry to help us graph the parabola. Because one side of a parabola is a mirror image of the other side about this line of symmetry. Okay, now it's just a matter of plotting a few extra points. So I'm going to make a table of points, x and y, and I'm going to pick some x values and find the y values that go with them. So a good place to start is x equals 0. So I plug 0 into the equation right here, into the function, and the y value, or f of 0, would be 5. So I end up with 5 if I plug 0 here in for these x's. So 0, 5, our parabola goes through 0, 5. 1, 2, 3, 4, 5, right there. Now here's where the axis of symmetry comes in handy. If I have a point over here that is this far from the axis of symmetry, there is going to be another point the same distance away on the other side, which would be right about here. So the axis of symmetry gives us an extra point every time we find one point. We get an extra one. Let's now try x equals 1. If I plug 1 in here to our function for x, we get 1 squared minus 6 times 1 plus 5, which works out to be, let's see, do scratch work here, 1 squared minus 6 times 1 plus 5. That's negative 5 plus 5. That looks like that's 0. So it looks like it goes through 1, 0, which would be right here. And because of symmetry, we would also have another point the same distance from the line of symmetry right here at 1, 2, 3, 4, 5, 0. Let's plot one more point. Let's try x equals 2. That would be 2 squared minus 6 times 2 plus 5. It's going to be 4 minus 12 plus 5, which is negative 3. And so our parabola goes through the ordered pair 2 comma negative 3. 2 and negative 3 is right there. And because of symmetry, we would have another point over here as well. Okay, we have enough points now to see the parabola. So we're going to connect the dots here. And there's our parabola. my sketch isn't the greatest here, but one side should be a mirror image of the other side. Okay, let's try another one. Let's now graph f of x equals negative 2x squared plus 4x plus 3. Okay, the first thing I'm going to check here is which way our parabola opens. I notice here that a equals negative 2, and so since our a is less than 0, we know that that means that our parabola will open downward, like that. So I'm expecting a parabola opening downward. Now I'm going to find the vertex by using the line of symmetry. X equals negative b over 2a. That will be negative 4 over 2 times negative 2, and that simplifies to a positive 1. So our line of symmetry, or axis of symmetry, is at x equals 1. To get the y part of the vertex, I take x equals 1 and plug it into my function here. So f of 1 will be negative 2 times 1 squared plus 4 times 1 plus 3. And if we simplify that correctly, we get negative 2 plus 4 is 2 plus 3, 5. And so we have found the vertex. The vertex is located at 1, 5. 1, 5. Okay, let's graph that. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can barely fit it on there. Our vertex 1, 5 right here. Here's our line of symmetry, or axis of symmetry, right through the vertex. This is the line x equals 1. And now we're going to plot some points. So I'm going to make a table of points, x and y. And I always like to start with 0. If x is 0, I'm going to plug 0 in here for x. I'll do my scratch work up here. That would be negative 2 times 0 squared plus 4 times 0 plus 3. That's just going to be 3. So our parabola goes through the ordered pair 0, 3. Right there. Because of symmetry, our parabola will also go through this point right over here. Because remember, our parabola has to be symmetric about this line of symmetry. Let's now try negative 1. Plug in negative 1. That would be negative 2 times negative 1 squared plus 4 times negative 1 plus 3. That's going to be a negative 2 times a positive 1 minus a 4 plus a 3. And that will simplify to negative 3. So our parabola goes through the ordered pair negative 1, negative 3, which would be right about here. Now, if it goes through a point there, then it's going to also go through a point the same distance away on the other side, which would be right here. Okay, I have enough points now to see the parabola. It's a rather skinny parabola. Connecting the dots. And there it is. There's our parabola. Okay. Sometimes you will be asked to find the x and the y intercepts for the parabola. So let's talk about that. To get the y-intercept, you set x equal to 0. And we actually did that right here. When we plugged in 0 for x, we got y is 3, and right there, we already have it as the y-intercept. But what about the x-intercepts? Where does this parabola cross the x-axis? That sometimes is a little harder to get. The y-intercept is at 0, 3, but where are the x-intercepts? Well, to find an x-intercept, what you do is you set y equal to 0. And if I do that, that means I'm plugging in 0 up here in place of the f of x, which would give me this equation. It would give me 0 equals negative 2x squared plus 4x plus 3. Now, I'd have to solve that for x to actually know where the x-intercepts are. And it doesn't factor, and so what I'm going to have to do is resort to using the quadratic formula. So let me make myself some room here. Okay, let me take this equation here, and let me move everything to the left side. I like the x squared term to be positive. 2x squared minus 4x minus 3 equals 0. Okay, I need to solve that for x in order to find the location of the x-intercepts. So I'm going to use the quadratic formula here. That's going to be negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And I'm going to plug in negative 4 for b, 2 for a, and negative 3 for c. And then we simplify. That's going to be a positive 4 plus or minus the square root of, let's see, that's 16 plus 24, which is 40. So 40 over 4. The square root of 40 simplifies to 2 square root 10. So this is 4 plus or minus 2 square root 10 all over 4. And I can factor out a 2 out of the numerator. And then I can reduce right here. And so what I end up with is x equals 2 plus or minus the square root of 10 over 2. Right there. Okay, and those are, I have two answers. Both of them are x-intercepts. If I use the plus sign, this x-intercept right here is at 2 plus the square root of 10 all over 2. And this one right here is at 2 minus the square root of 10 divided by 2. Now, just to verify that these are actually at least somewhat correct in the right place, if I type 2 plus the square root of 10 divided by 2 into my calculator, this value right here is approximately 2.6. So I'm at least somewhat in the right spot here. 2 minus the square root of 10 divided by 2 is about negative 0.58, and so this point appears to be in the right place as well. Okay, and so that's how we get our x-intercepts for our parabola if they're asked for. Let's graph one more parabola, one more example. Let's graph f of x equals x squared plus 2x minus 2. Okay, I notice that it opens upward because a here is 1. So since a is positive, opens up. Let's find the vertex. Oops, let's see, you got to find the line of symmetry first to find the vertex. Axis of symmetry. X equals negative b over 2a. That will be negative 2 over 2 times 1, which is negative 1. So our axis of symmetry is x equals negative 1. Plug negative 1 into the function to get the y value. F of negative 1 is negative 1 squared plus 2 times negative 1 minus 2. And if I simplify that correctly, that's going to give me a negative 3. And so we found our vertex. Our vertex for this parabola will be located at negative 1, negative 3. Right there. Okay, let's graph this. Negative 1, negative 3 is right here. Our parabola opens upward. This is our axis of symmetry. X equals negative 3. Negative 1, that is. Okay, now we're going to plot some points. We'll do that right up here. Okay, if x is 0, I always usually start with 0. Plug 0 into our function here, and we will end up with negative 2. 0, negative 2 is right there. Now, because of our axis of symmetry, there must be also a point right over here. Let's now try x equals 1. If I plug a 1 into my function, I get 1 squared plus 2 times 1 minus 2, which is a 1. So our parabola goes to the ordered pair 1, 1, right there. Because of symmetry, if there's a point here, there must also be a point right there. And I think that might be enough. Let's try one more, see if we can fit x equals 2 on here. If x is 2, I get 2 squared plus 2 times 2 minus 2, which is a 6. So 2, 1, 2, 3, 4, 5, 6. That would be way up here, actually. And we'd have another point way up there. Okay, connect the dots. And we have our parabola. Let's make sure that we have all the features that we might be asked for. Notice that there's the vertex. We have our axis of symmetry. We have right here, that is where it crosses the y-axis, that's our y-intercept. But what about the x-intercepts? We don't exactly know where they are. If you had to find them, this is how we would do it. To find x-intercepts, you have to set y equal to 0, or f of x has to be set equal to 0. And so right up here, I got to write in 0 equals x squared plus 2x minus 2. Now, since that does not factor, I have to solve this equation either by completing the square using the quadratic formula. Most people will use the quadratic formula here, so I'll do that. So solving this for x, I'll get negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 2. And divide all that by 2 times 1. Okay, quadratic formula. Now, if I simplify this correctly, I get negative 2 plus or minus the square root of 12 over 2. And that's negative 2 plus or minus 2 square root 3 over 2. Simplifying the radical there. If I factor a 2 out of the numerator, I can reduce like that. And so my x-intercepts are at negative 1 plus or minus the square root of 3. Right there. X-intercepts. So this one on our parabola must be the negative 1 plus square root 3. which if I use a calculator is about 0.73, which it appears to be in the right place. And this one over here must be -1 minus the square root of 3. If you use a calculator to get a decimal approximation, that is about -2.7. And so that appears to also be in the right position. And that's how we find the intercepts, and that's how we graph parabolas, and that is the end of this lesson.